So far what we've learned is that if I have a set of equations and they look like this, where they're equal to the same value, same variable, y, then I can use the equal values method and I set these two equal to each other. In the same manner, if I have another pair of equations, but they don't look like this, they look a little bit like this, where one is in slope-intercept form and the other one looks like it's in standard form, then I can use the substitution method by stating that since these two are representing the same unknown quantity, this unknown quantity equals that, I can replace this variable with this expression, then I go ahead and solve. But what happens when I have a pair of equations that are in standard form and they look like this? I can't use the other two methods, so what can I use? So we're going to use the idea of adding vertically, right? This would be 4, and you kind of break this up in parts, in columns. This is 1 plus 0 is 1, 0 plus 4 is 4, 1 plus 6 is 7. And then you have your answers, correct? And we're going to use this same idea for these type of equations. Now, again, we're being asked to figure out, do these two equations have anything in common? And if they do, what are those input values and what are the output values they equal to? We can graph them. Just plug these two equations in decimals, and using the geometric method, we'll find their point of intersection if it exists. If it doesn't, usually that means they don't intersect. They don't have anything in common. So, back to this algebraic approach. What we're going to do is we're going to stack these two equations one on top of the other. So I'm going to leave some room here. And there you go. And I'm going to use a different color just so you understand. I'm going to add. And by adding, I mean I'm going to do this. In fact, I'll use purple. I'm going to make columns. And then I add them. So, the key here is we want to eliminate one of these variables. And luckily, if I add positive 1y with negative 1y, I'm left with 0. And here I'm left with 2x equals, this would be 6. And I rewrite this equation as this. Now from here, I solve for x equals 3. I take this same value, and I can plug it in here or there. It doesn't matter. But then I get the value for y, which in this case turns to be 1, I believe. And that is it. Okay. Until next time.